Hello YouTube, and another video and another set of Christmas lights. You can tell it's just been Christmas. Well, it's not just been Christmas, it's February, but you know, we are people who put their trees away in February, don't we? So this one, apparently, they turned it on and it smells bad. That's all I've got to go on. So initially looking at these don't appear to be LEDs, and looking at the label, it says bulb rating 6 volt. 0.12 amps, 0.25 watt. So that's obviously 6 volt is very high for a LED, so it must be a actual filament bulb. So and there's no power supply, it's just literally plug lights. So 6 volt drop across each light, many lights, probably does equal 240. So yeah, let's plug them in and see if they smell bad. I mean, there's no initial sniff. Let's do a sniff test. Yeah, they just smell okay. So don't quite know why I've got them, but we'll turn them on and see if anything exciting happens. And let's turn it on and see if they smoke. 1, 2, 3. They don't turn on, do they? How strange. So yeah, it's plugged in. We're drawing, can you see that? 1.2 watts. Do you have a current for that? Amps. 0 amps. So no lighty. How strange. So, has whatever was smoking blown itself clear? To be honest with you, I was kind of expecting these to work. So that's kind of thrown me a little bit. Right, okay. Next thing to look at. So a quick resistance meter across the pins. Oh, it's come off. I've disconnected. Let's connect it back on again. There we go. Across the pins, we are open circuit, so there is no resistance. You'd expect there to be resistance. These are filament bulbs because they're all in series. So is it the fuse? Let's check the fuse. Alright, holding both ends with one hand, we have a reading of 13 mega ohms. That's 13 million ohms. That is a bad fuse. It should be short. So why has the fuse popped? So we'll check live to neutral now. You're going on to the terminals of the actual fuse holder. Going from live, which is the black lead, to the actual live of the holder, which is not the pin. The actual pin is this one, but this is the live that goes to the lights, and then neutral on the other lead. So we're going across the lights again. Still open circuit. So something in this lot here is open circuit. Could be a bulb. Could be the plug. If it smells, I kind of expect it to be the plug. I don't really want to buzz out every single bulb. That's just going to be annoying. We could go for the middle bulb and then work back, but again, it's a pain. So this is the first light in the string. So this end of the light, which is plug end, will be connected to one of these pins. So either the terminal here or this pin here. So we'll buzz that out, make sure it's connected, and then we can do the same with the end light and get the other lead. And then we know the fault will be either be in the lights or in the plug side. Does that make sense? I think it makes sense. Right, so I've got one lead in the socket, one lead touching the pin, doing this with one hand, and we are got continuity there. So this bulb to this plug, the wire is okay, and the connection is okay. So now we do the end bulb in the string to the plug, and if that's okay, we know the plug side is good, and it must be a fault within the lights themselves. That buzzing means there's continuity between the end socket and the same pin, which is a bit weird because it means both ends of the light string connected to this pin, which shouldn't be. That's a bit strange. Let's double check that again. And as you can hear, this is now the first lamp in the chain. Same pin. Okay, I'm a bit confused now, because basically what we're saying is the first and last lamp are both connected to that pin where they shouldn't be. The first lamp should be connected to this pin, the last lamp should be connected to this pin, or the connection in there, which is odd. Okay, it's confused me now. No, don't worry, I've just confused myself. Basically, I was measuring the resistance across all the lights, and that's why it will look connected, but it's fine. So what we've got here is the first lamp out, which I've just dropped, so I can't show you. But the last lamp isn't connected to any pin. So it looks like our fault is from the plug to this lamp, the last one in the chain. So something down this lead. So we'll give the lead a good look and see if there's any breaks in it. And then we'll take this plug open and see if the leads come off. If it's something as simple as that, poor connection inside the plug. That's what I'm hoping it is, because that'd be a nice easy fix, because otherwise I've got to find the bulb that's gone, and that'd be annoying. Blimey, is this health and safety gone too far? So it had the security screw in the plug, which I had to get out a pair of cutters. And then try to pull the plug apart. I can't pull it apart, it seems to be stake welded in, so you can't even take the plug apart. I mean, seriously, are people that paranoid? People are going to just electrocute themselves, have to glue the plugs together? Oh well, we're gonna have to, what I'll do, I'll cut this off and put a new plug on it. So, but I want to get in here just to have a look. So I want to try and cut this away to have a look, see if the wires have come off. Because we'll find out what's wrong with it, but it's just being a pain in the arse. Right, I'm gonna have to cut this. I've got medieval on it. Trying to cut these locking pins away. There's two there, and there's two at the bottom here. You see them going through there. It's just stupid. So right, pliers, cutters, just get this open. Well, brute force won't get it open, but this will. Oh, it's not on. But this will. Finally managed to get that open. That was ridiculous. So, anyway, I buzzed it out. This connection here is connected to the first lamp, this side. This connection here should be connected to the last lamp, but it is not connected. So, there's a break in the wire between here and here. I suspect is where these wires are pinched through here. It's quite tight and narrow, especially if you look in there. Can you see that kink in there? All the kinks in these wires. So I wonder if going through here, the forming of that has actually broken it. So what I'm going to do is cut the wires off, rewire a new plug in the end, and see if it actually works first. I found a plug, and a proper one with screws so you can take it in apart and stuff. God. And it's even got a 3-amp fuse inside, so I don't need to you know, put a nail in it to make it work. So I'll wire this in to that, cut the wires off about here or something so we haven't got the break in it, and see if they work. And the new plug is on there. And also remember, when you do wire a plug, this live connection should be shorter than the neutral connection, so that if someone does pull the wires out, the live disconnects first and the neutral disconnects last. See, it's another good design of British plugs. You have this space here to curl the neutral up. See? That's why it's shaped that way. Anyway, let's put the lid on and plug it in. So that's interesting. Disappointingly, it doesn't actually turn on. And I measured the wire, and the wire is indeed broken. And looking at every bulb I've taken out, the bulb is actually blown. You see in here. I measured it, but equally, can you zoom in on the filament? Can I kind of zoom in? Or do I zoom in? Whoop! That's how I zoom in. Right, can you see? I think you can just about see that there is no filament. There you go, you sort of see between the two claws. Just a crack of the bulb, or it's just the coating, but there is no filament at all. The filament is completely burnt up. I think that's what that, you can sort of see that deposit along the bottom there. You go, you sort of see that black deposit. I think that was the filament, but every single bulb has blown. So whatever's happened to this set, all the bulbs have blown, the plug has a broken wire, and the fuse has popped. So what the hell happened to it? I'm going to say this is just buy a new set of lights, because if all the bulbs are blown, it's cheaper just to buy a new set of lights, isn't it? So why the hell am I bothering? Yeah, it can't be that expensive. So yeah, it's interesting as to why everything's just gone kaput, but it has. Yeah. Defunct. I'm calling it quits, because I'm too cold and this is just getting silly now, because I'm not replacing every single bulb in here because I haven't got enough. Right, extra content. Oh, this is good. So I've had a word with the owner of the said lights, and we think we find out why they were blown. So these lights, with the dodgy plug, have been on for exactly 1 year. So they've been continuously on for a year. No maintenance, no nothing. And what happens is, so this is a circuit diagram of the lights. There are more lights than this. I've just been lazy and only drawed 6. So there are many more. So you've got 240 volts coming in, a fuse, and then each bulb or lamp. And then that 240 volts is divided equally across these lamps. So you get 6 volts across each lamp. Obviously, if you've got more, you've got more, and yeah, more drop. Anyway, so that's how they're meant to work. If you look inside the actual bulb, the actual filament, you have, there's your case, you've got your filament going up like that, you've got a bit of wire doing that, and then you've got your filament going along like that. So that's the bit that actually glows and gives you light. Then wrapped around the base here, you've got some wire, and this wire's got a special coating on it so that when you get high voltage across it, it breaks down. So for instance, let's say this bulb here blows. So what you have your bulb like that, and your wire going across, and your filament goes pop, and it's no longer connected. So you break the circuit. So instead of having 6 volts across this bulb, you have 0 volts across these bulbs, 0 volts across these bulbs, and 240 volts across both terminals here, because it's an open circuit. And when you get 240 volts across this wire here, the coating breaks down and it bonds to these legs here. So this becomes a dead short. Yeah, so you've got a dead short going across this bulb because its filament's blown. And that means what happens is, say this is your bulb here. Instead of being a voltage drop of 6 volts across it, it's a 0 volt drop because there's no resistance. And as there's no 0 volts, the number of bulbs that you're dividing that 240 out across is lower. So instead of each bulb getting 6 volts, it will get, say, 6.5, 7 volts. Right, so that puts every bulb under a little bit more stress, but that's okay because you'll notice it and you'll change the bulb. That is if you haven't left your lights on for a year and you haven't actually noticed it. So what happens is, over time, the other one goes and this one will go short, say. And then instead of, again, this is short, no voltage drop is shared across the remaining bulbs. And say, instead of being 6 volts, it's now 7 volts and 8 volts. And that puts the bulbs under even more stress. So you then get another one go. And then you get a cascading effect. And because your current going through all this circuit is limited by the resistance of the bulbs. So let's say this is a 6 ohm filament. When it's shorted, it'll be a 0 ohm, I don't know, maybe 0.1, 0.2 of an ohm. Effectively, it's a short. So the resistance, the total circuit resistance goes down because it's added up. So 6, 12, 18. So that's the total resistance of the circuit. But of course, as these bulbs blow, you get less than the resistance, more and more current flow. And then you get a cascade effect. When you get too many of these go, what will happen is that one will pop, that one will pop, and it'll be immediate. Pop, 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 pop. Until eventually you end up drawing 3 amps, which is your fuse. This is 3 amp. And these are probably slow blow fuses as well. So probably get up higher than this. And then your fuse pops. And that's what we've got. And that's why all the bulbs in this circuit are dead. Because we've had a cascading failure, like we've had 5 or 6 of these bulbs go out. That induces stress on all the other bulbs because they've got higher voltage drop. And then eventually you get to a point when the filaments can't take it. They'll all pop in, all in turn, because as each one pops, another one gets more stress. Pop, 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 pop. The total current draw goes up because you're lowering the total resistance of the circuit. And then the fuse pops. And that's why this lighting set is completely ducked. Right, thank you for watching. And hope that made sense. So for now, yeah, I'll say bye-bye. See you later. Bye for now.